Alright, so here's your test prep packet on rationals and polynomials. Let's look at it together. A little brighter, maybe a little bit more. State whether it's a polynomial or not. If it is, give its degree. So look at number 1. Positive whole exponents, yep, and the degree is 3. Look at the next one. Positive whole exponent, yep, and what's the largest exponent? 3 again. Here, what's wrong? We have a variable in the denominator. This is a rational, not a polynomial. So why not? You can say a variable in the denominator. That's what makes it not that. In fact, this would be another way to write this is 15x to the negative 1, and you would see that there's not positive whole exponents. All right, do you know how to form and write a polynomial? So we have zeros, and we're going to change them to factors. So there's the first step. And then can you multiply it out? So I'm going to multiply the last two. That's x squared, subtract 4, and then I'm going to multiply those that are left here together. So x times x squared, 3 times x squared, x times negative 4, and 3 times negative 4. Again, so if 0 is it, it's just x, and then x plus 5, x minus 4. So to multiply this out, I would start with the last two, and it would be x squared. 5 take away 4 is plus 1x, and then minus 20, and then distribute the x, and you get x cubed plus x squared minus 20x. Number 6, the zeros. So we have x plus 1, x minus 1, x plus 2. So I'm going to multiply the first two together because it's easy. That's x squared minus 1. And then I'm going to FOIL and go x squared times x squared times 2, negative 1 times x, and negative 1 times 2. Number 7, it says for each polynomial list its 0 and multiplicity, and then see whether it crosses or not. So for x, it's 0. If there's no x there, it wouldn't be. The multiplicity, the degree is 1, so it's odd, which means it's going to cross. The next one is positive 4. Again, it's odd, so it's going to cross. And positive 1, that's an even exponent, so at positive 1 it would touch. Turn the page. Zeros, 3, no 0, because there's no variable. So it's negative 2, and it's odd, so it's going to cross. And then it's negative 1, it's odd exponent, so it's going to cross. Number 9 here, x squared plus 2. So be careful. So x squared plus 2, if you make it equal to 0 and solve it, when you take the square root, they're looking for real zeros, what would be on the graph. So this would be imaginary, so we don't list it. So there's no real 0 here. But here we got positive 6, it's even, so it's going to touch. Here, the last one here, what is it? It's negative 1/2, and it's even, so it's going to touch. Here's negative 7, put that underneath. Odd exponent, so it's going to cross at negative 7. Number 11, can you find the x and y-intercepts of the function? So, and that's it. So in other words, so the x-intercepts here would be negative 2, 3, and negative 3. And the y-intercept would be plugging in 0, and you'd be 2 times negative 3 times positive 3. So that's negative 9, negative 18. Here, to find them, we have to factor first. So we factor out an x, and I have 6 subtract x squared. Now if I take 6 subtract x squared and make it equal to 0, I would add x squared to both sides. So when I square root this, the answer is positive or negative root 6. So x gives you the x-intercept of 0. And we have positive and negative root 6. The y-intercept, if you plug in 0, the answer is 0. In fact, they always match. If the x-intercept 0, then the y-intercept has to be 0. 13. It's factored, so the x-intercepts are easy to find. So it's -1, +6, and +1. The y-intercept, plug in 0 for x, and you end up with 1, -6, and -1 squared. So be careful. And the answer, if you're careful, is -6. Number 14, what I notice about number 14 is the last factor there could be factored further. So I'm going to factor it. It's a difference of squares. So then when I'm talking about the x-intercept, I know it's 0, -2, and ±1. And then for the y-intercept, I'm going to plug in 0. And 0 times anything is just going to be, remember, they always are going to match. If x-intercept 0, then the y will be 0. Number 15, can you tell me the power term when it's factored? So x squared would be the power term, and we would say as x approaches infinity, f at x approaches infinity, as x approaches -infinity, f at x approaches infinity, which means both ends go up. Again, x cubed, if you multiply it out, would be the power term. So positive x cubed would be as x approaches infinity, f at x approaches infinity. As x approaches -infinity, f at x approaches -infinity, which is this, both ends go up. This one, the right end goes up and the left end goes down. For the next one, the power term would be x cubed and x to the 5. So altogether, if we multiply it out, you'd add the exponents and get x to the 8th. So this means as x approaches infinity, f at x approaches infinity. As x approaches -infinity, f at x approaches infinity. Both ends go up, positive with an even exponent. Here we have negative x squared and x cubed and x squared. So add the exponents, and that's 7. So negative x to the 7 by adding the exponents. So that would mean as x approaches infinity, f at x approaches -infinity, and as x approaches -infinity, f at x approaches infinity. Which means the right end goes down and the left end goes up. All right, turn the page. Use the x-intercepts to find the intervals in which the graph of f is above and below the x-axis. So a little different kind of question, but that's okay. The x-intercepts are 2 and -4. So if I only draw the x-axis and I put down -4 and 2, I know the end behavior. The power term is x to the 4th, so both ends go up and it touches and doesn't cross. So that means like above, above, above for a plus sign. Here, if I look, if I draw x-axis, we have -5 and 2. The power term again is x to the 4th, so both ends are going up, and then it touches and doesn't cross over, so everything is going to be above. The only time it's 0 is at those numbers. Same thing here, same kind of question, right? -3 and 2, so all of it's going to be above. All right, let's put this together. So can you analyze and graph this for me? So if I ask for the domain or end, so power term here would be x cubed. The end behavior is as x approaches infinity, the function approaches infinity. As x approaches -infinity, the function approaches -infinity. So the right end is up, the right end's up, left end's down. The zeros in multiplicity, so we have a 0 and -3. 0 is even, -3 is odd. The y-intercept would be 0. So if I'm going to sketch this, already I know the y-intercept's at 0, and we have another one at -3. I know the right end goes up and the left end goes down. I know it's going to touch here and then come back up. So there's two x values I can definitely find that might help me. So I'm going to plug in -1 and -2. So -1 gives me the answer 2 times 1, which is 2. Negative 2 gives me 4 times 1, which is 4. So that one's a higher turning point. So negative 1 and 2, and negative 2 and 4. We now have a good picture of our graph. If I asked you what's the relative minimum, you would say it's at 0, 0. And if I asked for the max, a good estimate would be at negative 2 and 4. If I said, hey, where is this increasing? Well, from negative infinity to negative 2, and it's increasing from 0 to infinity. Where is it decreasing? Just from negative 2 to 0. Let's look at number 23. At any time you can press pause, right? If I'm going too fast, do the work. So the power term here is x squared, which is x cubed. So the right end goes up and the left end goes down. We know the zeros in multiplicity, negative 3 and positive 2. One it's going to cross and the other is going to touch. The y-intercept is going to be at 4 times 3, which is 12. So we can at least get a sense of the graph right now. So I'm going to fill in some points here between the intercepts. So like 1, negative 1, and negative 2. So if I plug in 1, I get 4. If I plug in negative 1, I get 9 times 2, which is 18. If I plug in negative 2, I get 16. So I know the left end goes down and the right end goes up, and I know it's going to touch here. So we're going to find where 4 is. Going to find where 12 is. That's my y-intercept. So here's 4, my y-intercept. It keeps rising. So up to 18. And then it falls back down just a little bit. So what would be the, if I connect these together, right? Which one would be the turning point? So we can say that there's a relative max at negative 118 and a relative minimum at the turning point at 2, 0. We know it's increasing from negative infinity to the turning point, negative 1. It's also increasing from 2 to infinity. It's decreasing in between, so that's from negative 1 to 2. All right, one more like that. 24. Power term, negative 2x, and to the fourth, when you add the exponents, that negative 2 is essential. Both ends are going to be going down. If I asked you for the zeros in multiplicity, negative 2 is just a constant. You need a variable, so no 0 there. But we have positive 3 and negative 1. Both are odd in terms of the exponents. The y-intercept, if I plug in 0, I get 2 times negative 3 times 1, so that's negative 6. So I know the end behavior. Both ends are going down, and it's going to cross at each one. So let's see what where the turning points might be. So in between, I'm going to find, well, we know the y-intercept at negative 6. Oh, I forgot the negative in front. When I did the negative, plugged it in. So this is actually a positive 6. It didn't make sense to me at first. All right, I'm going to plug in 1 and 2 to get a sense of it. So when I plug in 1, I get 32, big number. When I plug in 2, four cubed, 64. So it's like positive 128. So anyway, we're going to use that. So it's like way, 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 way up here. We'll just do one of those. We know this point up here, I just estimate, I'm not going to count to 128. So 2 and 128. So when we talk about the max, obviously it's at 2 and 128. We have no minimum, because there's no low turning point. It increases from negative infinity to 2, and it decreases from 2 to infinity. So it increases and then decreases. All right, turn the page. 2 more to practice. So the power term here, add the exponents x cubed if you multiply it out. So the right end up, left end down. The zeros and the multiplicity, 3, 1, and negative 2. And they all are odd. They're all going to cross. The y-intercept, you get negative 3 times negative 1 times 2. So that's 6. So I'm going to find negative 3, and I'm going to find 2, and negative 1. So if I do a little table of values, the 2 ones I'm going to look for are positive 1 and negative 2. So if I plug in positive 2 and negative 1. What did I do wrong? Oh, I should put this at positive 1. At negative 2, or are you telling me through the video, and then at 3. Here, I'll even use my little eraser thingamajig. All good. Can't even tell I made a mistake. So at 2 and negative 1, so let's try it again. If I plug in 2, I get negative 1 times positive 1 times 4. The answer is going to be negative 4. Then when I plug in negative 1, I get negative 4, negative 2, that's 8, and 1. So it's 8. So I'm going to find 2 and negative 4, and then 1, 2, 3, 4, 5, 6, 7, 8. Now the y-intercept's at 6. Negative 1 is going to give me the answer 8. Now I have all the points I need to connect and make my graph. So if I asked you for the max, it's way up there at negative 1 and 8. If I asked you for the minimum, it's there at 2 and negative 4. Where is it increasing and where is it decreasing? So it's increasing from negative infinity to negative 1 and from 2 to infinity. And it's decreasing from negative 1 to 2. All right, one more like this to practice graphing. So the power term here would be negative x, and you add the exponents to the fourth. Both ends are going down. The zeros in multiplicity, at 0, it's even. At 1, it is odd. And at negative 3, it's odd. 0 is also my y-intercept. See if I can do this one right. So I know that both ends are going down. I know at 0 it's going to touch. So in between here, it's going to come above and touch. I'm going to find values at negative 1 and negative 2 to help complete the graph. So at negative 1, I would get 2 times negative 2, which is negative 4. And another negative makes it positive. So that's 4. Negative 2 would give me 1 and negative 3 and 4. So it's negative 4 times 3, so it's 12. So we got 4 and 12. And I know there's a little blip there. I didn't plug in a half and do the work. I just know it crosses and touches. It doesn't. So I can approximate if I wanted to in terms of where the max is. We definitely have a max at -1 or -2 and 12. We could also think that 1/2 might give us another one too. If I plug in a half, it is what it is. So the minimum is at 0, 0. And then where does it increase and decrease? So it increases from -infinity to up here, what is that, -2, and it increases from like 0 to a half. It decreases from -2 to 0, and then again from like 1/2 to infinity, approximately. All right, enough of graph and polys. 27. Can you tell me the domain here? So what can x, no, I'm just going to write x can't equal. And so you can see it all comes from the denominator. This one's a difference of squares, so be careful. Here we need to factor and recognize the two numbers x can't be are 0 and 49. Only the denominator matters. This is +10 and -8. So -10, +8. Do the inverse. Here, factor out of 3. And you get x squared plus 2x minus 15. And then one more time, x plus 5, x subtract 3. So the two numbers x can't be are -5 and +3. Here, a little more work. -21 and -4. Do a substitution. Factor by grouping. And you get x plus 1 and 3x subtract 7. So the two numbers x can't be are -1, and then add 7 and divide by 3. So find different intercepts. If I want to find a y-intercept, I plug in 0 and I get +4/3. Again, plug in 0 and I get 13 over -23. Plug in 0 and I get the answer 0. Plug in 0 and I get -15 over -7, which is +15 over 7. Plug in 0. Oh, wait a second. Come back up here. X-intercept. That's from the numerator. So the x-intercept is 0. The x-intercept, again, comes from the numerator. There's nothing that removes the numerator. There we are. So it's 15. And then again, this isn't factorable. Nothing's removable. So, but the y-intercept, now I'm doing it right. So if I look at the y-intercept, I get -10, -3, and -19. So that's 30 over -19. 39, what are the vertical asymptotes? That's the denominator. You got to be careful to make sure nothing's removable. So as soon as I know nothing is removable, then it's just the denominator, and you don't write it with a slash. It's x equals. Here again, I just need to be careful that nothing is removable. So in the denominator, 2 times -5 is -10, and -3. So it's -5 and 2. So that's 2x squared minus 5x plus 2x minus 5, factor by grouping. So I get x plus 1, 2x subtract 5. Nothing's removable, so now I can give the answers. So it's -1, and the other one is +5 over 2. So it's the zeros of the denominator, but if something's removable, it creates a hole. How do I find the equation of the horizontal? So it's power over power. So 9x over x, which is 9. Here, it's 4x squared over 4x squared. That divides to 1. Here, we have 4x squared divided by 7x squared. So it's 4 over 7. give the equation of the oblique. So 1 degree higher, so we're going to use synthetic if we can. So it's y equals x plus 13. Here, use synthetic. So it's y equals 1x subtract 5, use synthetic. So it's y equals x minus 2, use synthetic. Oh, we can't, we got to use long division here for the oblique. So 2 divided by 1 is 2, and it's x squared. Nope, it's just x. So then it's 2x cubed, 12x squared, and 10x. Be careful subtracting. So 11, that's negative x squared. That's negative 5x. So negative divided by that is negative 1. I actually don't need anything else. So it's y equals 2x subtract 1. So I'm not even worried about what's left over after that. Once I have my line, I'm over. All right, let's graph this. So the domain and the intercepts. So let's factor it. So it's x plus 6, x minus 3, x plus 2. So the domain x can't equal negative 6. And the intercepts, we have one at negative 6. And the other one, when I plug in 0, is at negative 1. So that's a good place to start. Oops. Negative here, and then negative 1 here. Ignore that one. Asymptotes, we have one at x equals 3 and x equals negative 2. And we have horizontal at 0 because the bottom is more powerful. Is there a hole? No, because nothing's removable. What's the end behavior? Well, it's the horizontal asymptote. So as x approaches infinity, the function approaches 0 from both sides. I need a point over here somewhere, so I'm going to pick 4 or 5 or 6. One of those would be nice. Well, if I pick 4, 4 plus 6 is 10. 4 take away 1, 4 plus 2. So I get 10 over 6. So 4 and a little bit more than 1. So I know what this is going to do. On the other side, it's an odd, so it's here. It's not going to cross over at all. So I do have an intercept, so it's going to come back. So there's no other x-intercept, so the only way for it to go is back. It either goes to positive infinity or negative. Not positive because it's not going to cross the x-axis because there's no x-intercept there. And then here, this is above. You can cross over, but again, the end behavior here. So even though it crosses here, the end still is right with the horizontal asymptote. Number 50 here, factor. Recognize there's something that was removable. Now the domain still is x can't equal 3 and negative 2. We have intercepts. We have no x-intercepts. We only have a y-intercept at negative 1/3. We have one asymptote at 3 and another one at y equals 0 because the bottom is more powerful. Yes, there's a hole at negative 2. And when I plug in negative 2, I get 1 over negative 5. And the end behavior is the horizontal. So again, it's going to be 0. So we find negative 1/3. We find where 3 is. And 0. And we have a hole at negative 2 and negative 1/5. So that's up here. So this side I know. And hop over the hole. So I know the behavior there. I'll plug in a number over here, like 4. So if I plug in 4, I get the answer 1. So 4, 1. So now I have something to curve through here, and you have it. Number 51. So let's factor it. That's a 4. So x can't be 4 or negative 3. We have intercepts. Well, we're going to remove this now. So we have an x-intercept at 2 and a y at 1/2. We have asymptotes. So we have x equals 4 from the bottom, and then y equals, when you divide the power, it's 1. There is a hole at negative 3. So when I plug negative 3 in, I get negative 5 and negative 7. And the end behavior is going to be the horizontal asymptote, both sides. So we have 2, 0. We have 0 1/2. We have negative 3 and 5/7. And we have the one asymptote, 4. So 0 1/2, negative 3 and 5/7, a little bit higher than the Y-intercept. So you can see what this is guiding you to. Now I need a point over here. So if I plug in 5, I get 3 over 1. So 5 and 3. And then you finish your graph. All right, next page. Number 52. So x cannot equal negative 1. This removes, so I just have x minus 2. So we do have an intercept at 2, 0. And we have another one at 0, negative 2. We have no asymptotes at all. There is a hole at negative 1, and if you plug it in, you get negative 3. And the end behavior, well, this is going to be a line, right, where the right end is going to go up and the left end is going to go down. So the right end infinity, left end negative infinity. So find 2, 0 and 0, negative 2. The hole is at negative 1 and 3, negative 3. And then draw your line with a hole in it. All right, use the remainder theorem to do the substitution. So if I'm going to do that, be careful of the missing terms. So, whoa, is that too many? That's too many. 2 zeros at the end. So negative 1. So the remainder is 5. So there's your answer. The next one, don't forget, 0 and another 0, negative 3, a 0 and another 0, and 8. And I get 16. Let's see, 5, negative 5, positive 5, negative 5, negative 8, negative 8, and negative 8, and 8, 16. Yeah, because if I plug in negative 1, got it. All right, 55. To use the factor theorem, to see if it's a factor, we're just looking to see if the remainder is 0. So yes. This one's no. Don't care, the remainder is not going to be 0. Zero. 0. Make sure I'm doing it right. Well, this one works. So this one's yes. And then the last one here, do it over here. 0, 0. And it's clearly not going to work. So this one's no. All right, list the potential zeros. So positive, -1, positive, -5, positive, -1, 2, 5, and 10, the rational zero theorem. Positive, -1 and positive, -5. Here, you got to be careful of the 11. So put it over 11. Here we got positive, -1 and 2, and then I need all those denominators. So 6 is a denominator, and then 3, so I'm missing here. So 1 over 2, 1 over 3, and 1 over 6. And there, yeah, and then it's 2 over 3. Don't want to forget that one. 2 over 6 is 1/3, so it's already there. All right. One six, 1/3. Okay, I don't know what that is. All right, turn the page. So we're going to look for some treasure here. So I'm going to stop the video here because I ran out of time. So the last one, I'll do another video on it. And then you'll have 2 different videos. All right, good work prepping for your test.